G'day guys, how's it going? So this is another continuation video in terms of looking at string methods and slice methods. And where we finished up in the previous video was we were looking at the equals method, and we looked at just two ASCII based strings and slices, right? Now we can, just to test the theory on equals, it will also change or compare the casing of other languages, like in the case of what we've been using is the Greek language. If I come in and say for the first string, we're going to use the Greek word of that, and then we're going to tweak the casing a little bit on the next one, right? So this one's got the second character is uppercase, the character here is lowercase, right? So in the case of this, if we test for equality, it's actually going to say that these two strings are not equal, okay? Because they're not, right? But if we make them equal, like so, and run, it will say, oh, that's interesting. Let's run that again. There we go. So now it returns true for both, right? Because now they're both equivalent. Now, that's the equals method. There's also another method that is similar to equals but not quite the same, and that is the equals ignore ASCII case. So if I put equals ignore ASCII case, like so for both, and we run that currently with the same difference in Unicode, then this is also going to return false because these are different in case, but they're not ASCII, right? So if I now come in and set these to the same as we did before, you'll see true for both. But if I go and just type in, say, hello world, in all in ASCII, and then I just change the casing on it a bit. So let's say it's all lowercase here. What's going to happen is when I test for this equality using this method, it's actually going to return true. So this is a case insensitive, sorry, this is a regular case insensitive way of checking two strings. As long as the strings and the slices contain characters that are in the ASCII character set. Okay? So if I now change this to hello and lowercase world, this will still remain as true. But like I said, if we go back to EQ instead, well, it is going to consider casing in this situation, and that is why we got false for the equals here, but true here because we changed that, but not this. And now we're back to square one, right? Where they should both now be true. Cool. So that is the equals and equals ignore ASCII case methods. Now, you might ask, well, what if I want to change the casing in some of these words, not just compare the casing? Well, we have methods for that too, right? So let's say I'm going to go back to just having some string here, and we'll get rid of this and get rid of this. And I'll change this back to some slice. And this would be a reference to some string. And now let's say, for example, I want to see the some string as lowercase, right? And we want to also see some slice as lowercase. Well, it's pretty straightforward. We just go some string dot to ASCII lowercase. Okay, so this will only convert characters that are in the ASCII character set to lowercase. So if there are other characters, which we'll see in a minute, they won't be converted to lowercase. So let's do the same for the slice, just to prove that. To ASCII lowercase, and we go run. You'll see now everything's in lowercase, right? But if we take that same Greek alphabet that we had before, So this one here, right? We know that this is an uppercase character. If I now run this, well, strangely enough, the lowercase isn't affecting this character here. This is where we have just the regular two lowercase. All right, so in this situation, if we use the regular two lowercase, it will detect that this is Unicode. This will detect that this character is uppercase and convert it to the lowercase counterpart, to which it does here, right? So it converts it to this character here. Cool. So that's the distinction on the ASCII versus the regular two lowercase function. I'm not too sure why they exist. I believe maybe the ASCII one is faster if you're just dealing with ASCII characters versus the regular two lowercase, which probably has to go through and look at the rest of the Unicode characters and compare. But generally, I use two ASCII lowercase in my code when I'm dealing with ASCII characters. Now we can do uppercase as well. So we've got the same functions for uppercase. So we've got two ASCII uppercase for both of these. And run. And you got hello world and hello. And then once again, if I grab that Greek alphabet, this time I'm going to make that character lowercase to begin with and run. You'll see nothing changes. But if I use the regular to uppercase, it should, right? And bingo, Bob's your uncle, right? So that's the casing related stuff. But with this solution, what we're doing is we're actually returning a new string, right? What if we just want to modify the string in place here? All right, so in this case, we're not going to be using slices because, well, you can, but in fact, we will. We will. Let's use slice here. So say we want to update the string in real time. So we'll go back to hello world to make it easier on ourselves. We can, instead of just printing out down here, well, first we need to mark both these as mutable. Right? And we need to get a mutable reference here. Right, so that gives us a mutable slice and a regular string, a mutable string. And then what we can do is we can basically print out some string before it's modified. So let's just do that quickly. And I believe that to make this easier on myself, I should do all the string related stuff first, then the slice related stuff, and that will get around some of the ownership issues. So printing the string beforehand. Then what I'm going to do is I'm going to call a function which will convert it to uppercase. So that is some string dot make uppercase, ASCII uppercase. And there is no make uppercase, by the way. So if you're using the Greek alphabet, I don't believe there's a method, at least yet on the string, where you can convert it to an uppercase. But anyway, it's just called make ASCII uppercase. And then we'll print out the same string again, right? Just to indicate that it did change. And then we can also convert it to lowercase by calling make ASCII lowercase. And then once again, we'll print out the same string like so. And let's ignore slices for a second and just check to see that this actually changes some string in place. There you go. You can see some string has been modified because we've made it mutable and we've called this function. And now let's just see that it works with slices as well. So what we'll do is we'll do a similar pattern we've got here, except I'll convert things to some slice. Cool. So I'm going to comment out the first lot and run this. And we can see that the slice has changed, right? So we'll be able to mutate the slice. But because we had a mutable reference to the underlying string, what should happen is when we print out the string as well, it should be whatever the final result is of the slice plus the original world word, if that makes any sense. So let's have a look. And you can see when we started, we had a capital H for hello, but because we called lowercase on the slice, it in turn modified the string that was the original owner. And you can see now the original string has a lowercase h. All right, so that's how we can modify the capitalization of strings and string slices in place. And just keep in mind that when you modify a string slice in place, you're also modifying the underlying string. Now let's talk about replacing. So let's go back to our example of, let's just use a regular string. So we'll keep it mutable for now. Though I believe we don't need to make it mutable. Yeah, let's get rid of the mutable keyword for the moment. So if I want to get the result of a replacement, so say with the string that we have here, I want to replace the word world with my name, which is Daryl, right? So I could do something like this. First, let's go print line, and we'll just print out some string so we can see what it looks like. And then straight after that, I'm going to go let new sum string equals sum string dot replace. Right? I'm going to look for the word world, and I'm going to replace it with my name, which is Daryl. Cool. And then what I'm going to do is I'm going to prove that some string stays intact. It should because it's mutable. So let's just prove that for sure though. And I'll also print out the new sum string just to indicate that it will be what sum string was, but instead of it saying world, it will say Daryl. Cool. So let's quickly check that. And there you go. So it's sum string was hello world. Then it's still hello world after the replace. But new sum string is, well, hello, space, and then my name. Whereas it said world before. Cool. So now let's just quickly see this with slices as well. So we can pretty much grab most of what we have here. And I'll just change a few things up. So now we're just going to grab the first word as we have in the past. And now I'm just going to go some slice. Whoops. I did a copy instead of a paste there. Now this replace will continue to return a string. So this should be new slice string. New sum slice string. Right. We'll see that the slice remains the same. And just to remove some confusion here, let's get rid of some of the output. So now we're just going to see that some slice doesn't change. And we could probably even prove that some string won't change because we're returning a string, we're not modifying the existing string. So let's do that. So run this. And we can see some slice was hello before, it's hello after, some string is still hello world, and the new slice string is just hello. And what I should have done, which is silly me, is I need to change it to something that was in the string. and now run it. So hello should now say goodbye. There we go. So where it said hello before, it now says goodbye. Cool. So that is the replace method that's on strings and slices. And then the last one that we'll look at is the repeat function, which if I do something like ABC here, and then I go print some string, and then some string repeated twice, I can come here and go dot repeat twice, or two in this case, right? And then we can do the same thing down here for the slices. So we've got the first word. Oh, sorry, it'll be, let's just go the first letter. All right, so we're going to grab A. And in this case, I'm going to go some slice. And then I'm going to repeat that slice 3 times. So some slice repeated. What's the word? Thrice. And go repeat 3 times, some slice. Cool. And we can get rid of the rest of this code here. So this will now demonstrate for both slices and strings that we can repeat them. So we had ABC for the first string. We said we wanted to do it twice. So now we get ABC, ABC. And then some slice was just an A before. And we said do it thrice. So now it's AAA. Cool. And that is where I'm going to end all the methods for string and slice. Now, there are more, and we'll look at a few later on as we go down the line. But I think that's exhaustive enough for now for you guys to have a reasonable grasp of what you can do with strings. So in the next video, we're going to look at the last piece of memory I want to talk about, which is basically constants and slices as literals. So I'll see you all then.